Hey everyone, Happy New Year. Thanks for joining us and welcome to our first CIIR talk in 2021. It's our pleasure to have Professor Krisztian Balog from the University of Stavanger in Norway with us today. Krisztian is leading the Information Access and AI Research Group, and he's also an adjunct professor at the Norwegian University of Science and Technology. And recently he has been visiting Google for a couple of years. Krisztian is working on a lot of different areas related to information retrieval and recommendation. And his main research interests lie in the use and the development of information retrieval, NLP, and machine learning techniques for intelligent information access. And he's done a lot of work related to entity-oriented and semantic search and novel evaluation methodologies. And as most of you know, he's an active member of the IR community. He has served as this program committee member and senior program committee member at a lot of major conferences in IR. He has served as lab co-chairs in Clay and Track. He has been a PC chair for CIIR and a general chair for, again, CIIR and ECIR. And he's a recipient of the 2018 Karen Spark Jones Award. Please join me to welcome Krisztian and ask him to talk to us about what does conversational information access exactly mean and how to evaluate it.
Yes, thank you very much for the kind introduction and for the invitation. I'm really honored to be with you virtually. And this talk will have two main parts. And the first part is my perspective on conversational information aspect. And my perspective is emphasized here because I want to make this part maybe a bit provocative or critical. And I will be more critical than I would normally be. But I would like to make use of this seminar setting so that maybe throw in some ideas that can help generate a good discussion later. And in the second part, I will focus on some recent work in the context of conversational information access, which will try to address some of the issues that I will identify in the first part. And if I have to give the gist of the talk, then I would like to get two main points across. One is that in recent work, and maybe in all the work that has been done and labeled as a conversational IR, the conversational aspect has not received that much attention. And I will explain a bit more about what I mean by that. And the second point is that it's perhaps due to the fact that evaluation is a bottleneck and we don't have appropriate methodology and sufficient resources. Okay, so in the first part, I want to answer this question, and you might ask why is this a question in the first place? And the reason is that I feel that many people have a very different understanding or a notion of what conversational information access should mean or could mean. And I intentionally use the term information access to emphasize that I mean both search and recommendation. So not just conversational search, but I also think that recommendation should be part of the problem setting. And a small disclaimer that it's really work in progress. So yeah, I really would like to hear your feedback and comments on these ideas. So one of the questions that I'd like to ask is, where does this conversational information access problem fit within the broader space that is usually referred to as conversational AI. And if we look at surveys, then a traditional distinction that is made that there are task-oriented systems or goal-driven systems and non-task-oriented or non-goal-driven systems. Task-oriented systems aim to assist users to solve a specific task as efficiently as possible. And there is a dialogue flow, typically very clearly and often rigidly designed, that that users are expected to follow, and this address is typically a closed domain. So flight or restaurant reservations are a canonical example of task-oriented systems. And it's very easy to know when the system succeeded because the task that the user intended to do was completed. On the other hand, non-goal-driven systems aim to engage users and entertain users in a way, so they are often referred to as chit chat. And the point here is just to mimic human conversations. These are typically unstructured and open domain, and the main objective is to be as human-like, as engaging as possible, be able to discuss different topics in breadth and depth and in a coherent manner. Now, in a more contemporary distinction, you might notice that QA is added as a separate category. And the reason, I suppose, is that because it doesn't really fit any of the other two categories. It's not really driven by a very clear task or goal. The goal generally could be to explore information, find out, learn about the topic. And there is not a rigid structure, although the dialogues typically follow a question-answer pattern, open domain, and the aim of the system is to provide a concise and direct answer to user queries, and the correctness of those answers is the main evaluation criteria. So if we focus on this distinction, then we could say that conversational information access fits two categories. Task-oriented systems and interactive QA are both flavors of conversational information access. And I will focus on those two types of systems and leave social chat out. So now, at this point, one might ask, well, hasn't search always been conversational? Even from the very early days, there is this view of search as a conversation between a user and the search engine. And the user issues a query, for example, places to visit in Stavanger. And that's a query you might want to remember, because in 2022, ECIIR will hopefully be held as a physical conference in Stavanger. And then when you come and visit us, you might want to check out what you can do in our wonderful city. And then the search engine responds with a search result page. And it provides an answer to this query, and it's left to the user to figure out in a way what exactly they want to take as the answer. In a way, it overwhelms the user with information, hoping that the answer to the question is also found on this page. But modern search engines also invite interactions. So there are different information panels. They show you entities, and one purpose it can serve is disambiguation. So you asked for Stavanger and you meant this city in Norway, right? And would you be interested in other cities in Norway, or do you want to know more about Stavanger and ask some queries that other users are asking? So there are all these elements that invite the user to explore further or help clarify the information need, but there is a number of critical differences. And these include the degree of personalization and the long-term user state. So the expectations are different for a personal assistant and for a search engine. A personal assistant can exhibit more personalization and is expected to do that, while a search engine may be seen as something that should be more objective. There is no good support for complex tasks, and by that I mean multi-step tasks. Also, there is this main issue of answer generation versus answer retrieval, and I will come back to that. But search engines retrieve answers, they don't really generate answers in a personalized way. And this search engine result page-based presentation is unsuitable in settings where there is no screen or no keyboard. Finally, it's always the user who is driving the conversation, and conversational search should be mixed initiative, meaning that the search engine should, or the conversational engine should also be able to take action. Now, at this point, you might say that it has taken me a very long time to arrive at something obvious, which was described in this Swirl report in 2018. So for those that don't know, Swirl is a strategic workshop that is held every 5 or 6 years, where information retrieval researchers are invited to gather and discuss what they regard as important challenges for the field, and in a way define a research agenda. So according to this research agenda, conversational information seeking is concerned with a task-oriented sequence of exchanges, and it supports user goals that include complex information seeking and exploratory information gathering, multi-step task completion and recommendation, different channels, long-term user state, user needs beyond topical relevance, and so on. Now, if this is already written, then why haven't I just started with this Swirl report? And the reason is that I feel that there is a disconnect. On the left-hand side, there is this what I call siloed view, which is the current practice, that we develop very different types of systems for different scenarios. And on the right-hand side, there is this grand vision of a conversational information access system, which should be able to cater for all these modes or scenarios. We can call these different user goals. Now, if you look at recent surveys, they focus on these 3 main categories, and then somewhere in the end, they mention that, by the way, commercial systems are actually hybrid systems, which need to combine all these different functionalities, and there is some broker that does that. And to the best of my knowledge, there is very little academic research on that. And the point is that there are very different architectures developed for these different user modes. And on the other hand, this distinction, which makes a lot of sense to us, and these different modes require different types of systems, from a user's perspective, they don't care, and they don't need to care. So the question is, and one of the main research challenges, which is an open challenge, is, can we develop a unified architecture that supports multiple user goals? And I have an example scenario here, which is super simple, but already this one will illustrate the point. As a user, I tell the assistant that I'd like to buy some running shoes, and I would like to have something similar to my Nike. And then this assistant should know what Nike model I have. And then it responds that there is a new model of the of the shoe line that I'm currently using. Also, I might want to check out a different brand which has better anchor support. So this illustrates the point of the assistant or the conversational agent taking initiative, but also I don't know what anchor support means and why it matters. So I can ask about that, and then we would be entering into a QA scenario. So one takeaway point is that it's perhaps time to embrace a more holistic view of conversational information access instead of focusing on those very specific scenarios and treating those modes separately. I should also acknowledge progress, that there has been a lot of progress on different components. And I'm not going to go into details or even attempt to make an exhaustive list. There has been great work on intent detection, asking clarification questions, query resolution, response retrieval. But an argument I want to make here is that most of this work has been on the component level, and it benefits conversational information access, yes, but many of these things would benefit general web search just as well. So they are not necessarily specific to the conversational paradigm. And to illustrate this point further, I want to bring up the track conversational assistance track as an example. And at this point, I just want to make a small disclaimer, so please don't get me wrong. I don't want to pick on the track track. I think it's a great initiative. There are just some issues that might be worth highlighting here. So the setup is the following. Given a user utterance, the system should retrieve an answer from a corpus of paragraphs. And then evaluation is performed with respect to answer relevance. So on the right-hand side, you can see an example. This is an actual example from last year's edition. User asks, what is throat cancer? System is supposed to answer. Then the user asks, is it treatable? And then the main challenge for the system is to resolve it so that it refers to throat cancer and retrieve an answer. And then there is a conversation. Now, there are a couple of issues with that. One is that evaluation is limited to single turns, and it actually doesn't really care about what the system responded to previous utterances. Also, the sequence of user questions is given beforehand. So it doesn't really matter how the system responds. The user would always follow up with a fixed question. Answers are limited to existing paragraphs, and actually the systems are required to return a ranked list of answers instead of just trying to find one single one. And one might argue that co-reference resolution is not really specific to conversational search. It's been studied in the context of web and session search. There was a Bing paper a couple of years ago, and I didn't manage to refine it, but some of you might have the reference, where in query chains, this co-reference resolution has been done in Bing years ago. And if we look at it from a distance, then is the task that we are addressing really different from passage retrieval? So on the again, there feels to be some disconnect. We could look at conversation as a tree, which starts with the user utterance, and then the system could respond in different ways. And at each turn, this conversation can branch in many different ways. And what the user asks should be dependent on the previous one. And what is happening instead, that there's a fixed chain of user questions. And even in that chain, we are just focusing on single query response pairs. It's important to acknowledge that all test collections are abstractions, and that means that some simplifications need to be made. But it's important to make sure that we are not abstracting away the wrong things. Okay, so to be fair, and then in defense of the track cast track, I want to go back to the previous Swirl report, one from 2012, where conversational answer retrieval has been identified as a grand challenge. And what they are doing at track is very much in line with this task. There is one aspect, this rich user system dialogue, which has been identified as a crucial component, which I think is missing. And a critical person might say that, well, there has been a new Swirl report since, and this is 2012, and the track started in 2019. So why not consider the updated list of challenges? Okay. The main takeaway point for this part is I think we need to think as a community more about what really makes a conversational experience good or bad, and then make sure that we develop appropriate evaluation resources. Okay, moving on to the next part, I'd like to talk about answer generation and how it is different from answer retrieval. And in the next two parts, I will also be guilty of taking this siloed view and focusing on this interactive QA mode in this part. As a motivation example, consider the query, what is the largest field sports stadium in the world? And one possible system answer to that would be the AT&T Stadium in Arlington, Texas, USA. Another option would be the same, but adding that this stadium can seat over 80,000 people. Or a third alternative would be the stadium, home of the Dallas Cowboys, which can seat over 80,000 people. Now, if it was a physical setting, I would do a quick voting round to ask participants which option they think would be best. And I suppose many would say 2 or 3. And whether you prefer option 3 over option 2 might have to do with if you know anything or care at all about American football. Then that might be a useful piece of information for you. The point I'd like to drive home here is while interactive QA is defined as giving a direct and concise answer, I'm not sure that being as concise as possible is actually a desired thing in all cases. And it is an open question, at least to me, to identify what makes it a good response in a conversational setting. Again, I'd like to refer back to the Swirl definition and highlight 2 of the aspects of conversational information seeking, which it actually states going beyond topical relevance and how things are presented in addition to what is presented, and the summarization of potentially long or complex answers in easily consumable units. Okay. So let me give you another example. You might ask, what will the weather be like next week? And the answer would be this weather forecast in a tabular format. Since we established that conversational information access should also cater for a screenless and voice-only environment, how could we summarize this information in a voice-only environment where there's no screen? And one option would be to try to read out this table line by line, and then it will say today it will be sunny with temperatures between -6 and -2 degrees Celsius, tomorrow, and so on. And then from Monday to Wednesday, it would repeat almost the same, that it will be rainy. Now, another option would be to say, okay, today it will be sunny. Over the weekend, it will be overcast with max temperatures around 2 degrees Celsius. From Monday onwards, it will be rainy with temperatures between 2 and 6. And additionally, if the agent would want to drive the conversation forward and maybe even attempt to be a bit humorous, it could even add, well, if you think that's depressing, you should look at the wind forecast. Okay, so this sets the stage for the problem I'd like to talk about next, and that's presenting tabular results in a conversational setting. And there are two main requirements. One is that this summary should not be static, but should be conditioned on the conversation context. And ideally, it should also help drive the conversation in a way, invite the user for further exploration. Going back to the example about the sports stadiums, for this query, there's a table which contains the answer. And there's a large portion of queries for which the table can be found in an answer. Then in this work, we hypothesize that a good answer would have three main components. One would be a leading sentence which describes the source of the information. And assuming a multimodal interface, there could be a link on the table so the user could check the source of the information. So the agent found a table listing the stadiums. Then the second sentence is a direct answer to the question. And the third sentence tries to bring in some other information that should help the user explore further, to help drive the conversation further. Now, I have no, formal or even experimental proof that this is a good answer. It is built on intuitions that these would be desirable traits of an answer. And you might even ask, well, would people actually want to be engaged in a conversation? Is there any evidence on that? And the quick answer is that it depends. There is a Google paper that appeared at the web conference last year. And this is interesting because this is one of the few papers which report on live experiments which have been performed using the Google Assistant. And this particular study was done on NBA-related questions. And the paper focuses on modeling aspects, but I want to focus more on the experimental findings that are really interesting. So one finding was that by complementing the direct, concise answers with additional facts, user engagement increased. So if you check the first question on the right, then instead of just giving the total score, they also tell who the top scorer was. And then instead of just telling how many points he scored, additional statistics are given. So this in general helps, but one finding was that explicit negative feedback also increased. So people at some point were just interrupting the assistant, stop, I'm not interested. And in many cases, that was when their team lost. Then they were not interested in having a further conversation. So generally, yes, more engagement is and the assistant trying to drive a conversation is desired, but it's also highly context dependent. And it's an open question, when should it try and how hard it should try to make a conversation instead of just giving you the number that you were asking for. Okay, but back to our work. What we are trying to do here is to create a test collection for a table summarization in a conversational setting. For this task, the input is a query and a result table that we know that it contains the answer to that query, and the output is a summary. The queries and tables, the tables are sampled from the Wikitable questions dataset, and we restricted ourselves to tables that had a certain size to make sure that summarization makes sense, and the table is large enough so that it couldn't be displayed in its entirety. And then some questions came with this data set. Other questions were written by authors of the paper. And on the right, you can see two examples. And these resemble real user questions with the typos and grammatical flows and lack of capitalization and what have you. And you might also notice that these questions, especially the second one, are likely to appear somewhere in the middle of a conversation. This is not a conversational opener question, but from the answer, we know that he refers to a certain Chinese actor. Okay, so we want to create a test collection, and it's done using crowdsourcing and set up as a multi-step crowdsourcing task. In the first step, workers are asked to create candidate summaries, and the instructions are especially interesting here, I think, because we need to put them in a context or in a situation where it would make sense to having to describe a table in words. So what they were told is that they should imagine talking to a friend on the phone, and they need to help that friend with a question. And after searching the web, they find a table that contains the answer, and then they need to write a summary of the table in a similar way that they would explain it over the phone. So the summary was between 30 and 50 words, which corresponds to 15 to 30 seconds of spoken English. And 5 summaries were created per query. Then in a second round, these summaries were assessed both on the summary level and on the sentence level. On the summary level, assessors were given the question and all the candidate summaries in random order, and they were given a set of guidelines according to which they need to consider language quality, relevance, and ability to drive a conversation. And based on those criteria, they are asked to select a single best summary. And in the end, the summary that received the most votes is selected as the ground truth. And we asked 7 assessors, and in 77% of the cases, at least 3 of them agreed on which summary was best. So that's good. One interesting observation was that these top voted summaries tend to be longer a bit than average summaries and use a richer vocabulary in terms of more unique words. We also performed assessments on the sentence level, where summaries are split into sentences, and assessors are given a task where they have to write basically the summary, and they are given these sentences as input. And for each sentence, they need to decide how relevant would that be in writing the summary. What follows next, we focus on the summary level assessment, but the sentence level ones are part of the data set. So I just wanted to mention it here. Okay, this was a a short CIIR paper last year, and the goal was really to introduce this task and establish a baseline and identify challenging aspects of the task. So we weren't developing new models, but instead tried to apply what were at the time state-of-the-art pre-trained neural language generation models. And then we did some fine-tuning on the limited data that we had using five-fold cross-validation. Since we had 200 query table pairs, it meant that fine-tuning was really done only on 160 tables, so that's not much. And one technical aspect that needs to be considered is how to represent tables as a text sequence. And here, a key value format was used, where in addition to the value cells, also the page title, the table caption, and the total number of rows were added. This table shows the results. And I mean, the results are not that surprising in a sense that more advanced text generation models perform better, and the results are encouraging, even with little training data. Some of you might ask, okay, why do we use these measures, and how well is word overlap based and translation based measures capture what really want to do? And that would be a very good question. And personally, I don't like these measures very much, but that's what we have so far, and that's what is used in the literature. And I think they should be revisited. Okay. Something that's possibly even more interesting is to look at the summaries that were generated. And on the right, you can see one example where the bottom one is the T5 generated summary that was the best performing model. And above that is the manual ground truth summary. And you can see that it's surprisingly good. It can pick up useful attributes. It can generate a summary in fluent English. Some typical mistakes that we made were typically related to working with quantities. So in many cases, it was just a random number when it was it was about an aggregation. One example is where Purdue won 4 consecutive championships, and in fact it was 3, but the model doesn't really have an understanding of arithmetics, and sometimes it picked up the wrong column from the table, where there were subtle differences. For example, the elevation versus the prominence of a mountain. Okay. So the summary of this part is that I think response generation is an open research challenge. And instead of just retrieving passages from a large corpus, we should consider what makes it a good response, and how can we generate responses, and how can we explain and summarize complex information objects. And you can see the link here to the repository that contains this data set with the queries and tables and assessments. Okay, in the last part, I want to switch to end-to-end system evaluation. In the previous part, it was focused on a very specific component and the turn-based evaluation. And instead here, I would like to look at task-oriented systems and how to evaluate automatically task-oriented systems end-to-end. And the task I'll be looking at is conversational item recommendation, where the task is to find an item that the user might like from a large collection of items, and the system needs to elicit preferences on categories of items or specific items, and then make suggestions, let the user critique those suggestions, and so on. By the way, an interesting question is whether this is really a search or a recommendation problem. It kind of depends on if you're an IR person or a Rexis person. I would argue that an important element of this would be the long-term user memory and being able to proactively generate or create recommendations initiated by the system, and then that would make it a recommendation problem. Okay, just very quickly through this part. So there's test collection based offline evaluation, and we have covered the downsides of that, I think. And then there's human evaluation, and using human evaluation, it's possible to annotate entire conversations, but it's extremely expensive and time consuming, and it doesn't scale. So in this work, we are trying to explore user simulation as a means of end-to-end automatic evaluation. And specifically, we would like to develop a user simulator that can produce responses that the real user would give in a certain dialogue situation, enable automatic assessments of conversational agents. And this simulator should make no assumptions about the inner workings of the agents. It should treat them as black boxes and should be able to set it up using only a small amount of training data that was collected maybe with humans interacting a bit with the black box agent. So formally, for a given system S and user population U, the goal of user simulation U star would be to predict the performance of S when used by the user population. And what it means is if we have two systems, S1 and S2, then this simulator should be behaving in a way that if system 1 scores lower than system 2 according to some evaluation metric, then user simulation would yield the same relative ranking of systems, basically. Okay, so I need to go quite fast about the approach. I will just try to give you the main ideas and then invite you to read the paper for further details. This is the overall framework, and it very much follows a standard dialogue system architecture, where there is a natural language understanding component translating agent utterance into a structured format. What you have to be mindful of that on the left, that's the agent, that's the black box. We don't know anything about that. And we have another agent which simulates the user, which has very similar components. Then there's this response generation part. I will say a bit more about that with two main components, the preference modeling and interaction modeling. And then this structured response is turned into a natural language utterance that's sent to the agent. We model dialogues as a Markov decision process, and this is a very standard approach from dialogue systems. So we have a state space, an action set, and transition probabilities. And we have a dialogue state at each dialogue turn, and there are different actions that can be taken, and then there's a probability of transitioning from one state to another. And we used an agenda-based simulation framework, which is basically a stack-like representation for user actions that is updated dynamically. What it means is the user has a plan in mind, and the user is trying to execute that plan. And then based on the system's responses, it can either conclude that the step was completed and move on to the next one, or need to re-plan the agenda and make another action if the system doesn't respond as expected. So to make this work, we need an interaction model which tells us how this agenda should be initialized and updated. And one of the contributions of this work is an interaction model. So the action space is based on previous work and actions that were identified. And then there is this conversational item recommendation model, which defines what are the transitions between the different states. Then there is a preference model, which is meant to capture how what the user likes and dislikes. And this is the part where one of the main ideas lie, I think. Instead of modeling preference for single items, we leverage the notion of personal knowledge graphs. And to make a quick detour, a personal knowledge graph is a resource of structured information about entities that are of interest to the user. And it's basically a knowledge graph that captures the likes and dislikes and interests of the user. The point of using a personal knowledge graph is that during the dialogue, there might be questions about the preferences of the user which weren't predetermined, and then we can infer those and populate this personal knowledge graph on the fly, and we can make sure that the simulated user doesn't give inconsistent responses. So it will be initialized with some data, and then this graph will be populated during the course of the conversation. And then this is used as a kind of persona of the user, and it helps to make sure that all the responses are consistent. Okay, let's move on to the evaluation part. What we did was we compared the 3 movie recommender systems using both real and simulated users. And for the real users, we used crowdsourcing and asked people to interact with these agents. The interesting part is the simulated users. So what we did was we used movie lens data, and then we took one part of that as historical user data, and the other part as held out data. And that gives us a bigger set of items that the users like and dislike, and just a set of items with preferences, as opposed to other lines of work which is based on reviews and usually has a very small number of items that the users ended up purchasing. Okay, so 3 research questions. One is how well different simulation techniques capture the characteristics of conversations. And what you will see basically in the following tables is there's a line corresponding to the real users, and then there are 3 simulators which are increasingly more sophisticated, using better, more refined interaction model, or using personal knowledge graphs instead of single item-based preferences. So the short answer is that they resemble more real conversations. Perhaps even more interesting question is how well do relative system orderings correlate with real users? And we can see here that based on reward and success rate, which are standard metrics in task-based dialogue systems, with one exception, the simulated users yield exactly the same system ranking. And one final experiment we did was we gave users transcripts of 2 dialogues. One was performed by real users, another one was performed by simulated users and asked them to guess which of the two was the human. So you could think of this as a kind of reverse Turing test, and the goal would be, if we can fool the human evaluators more, that would mean the simulator is more human-like. And what we found is that the best simulation method, the last row, we managed to fool the users in 36% of the cases, and it was a tie in 23% of the cases. So that's quite impressive, I think. Okay, so the main contributions are of this work were the simulation framework, the interaction and preference models, and experimental comparison, as well as some analysis that you can check in the paper. And I need to wrap up here. I think the main message of my talk would be that it's perhaps time to move from search engines to conversation engines, and consider what really makes a conversational experience successful and unsuccessful, and embrace a more holistic view that can cater for different user goals. And to be able to make progress on that, I think evaluation is a bottleneck, and we need to work on evaluation methodology and resources. And I hope that the work I presented was an interesting step forward in that direction. I just want to take a minute to acknowledge my co-authors, Shuo Chang in the first place, who is my former PhD student and is now at Bloomberg, as well as Jamie Callan and his PhD student from CMU. And with that, I'm open to questions.